Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh, and I will be your host for today's event, in which we're going to tackle really one of the most interesting trends that we're seeing in the industry, and it's actually been going on for quite some time. It's just one of those things whose time has apparently come. The exact title is Empowering the Business with Agile Analytics. We're going to be talking about things like data hubs and analytical sandboxes today in the briefing room. And yes, in a moment I'll post a link to the slides in the chat window, so watch for that in just a minute or two. There is a slide about yours truly and enough about me. So the mission, as many of you know here in the briefing room, is to reveal the essential characteristics of enterprise technology. You play a significant role in that process by asking good questions. So what we do is we get vendors and independent analysts, and we pair them up in a live format. They do not coordinate before the show, and the idea is we want to preserve the kind of natural conversation that occurs when an analyst takes a briefing from a vendor doing something interesting in our space. So you get to ask questions as well. There will be a 10-minute Q&A, sometimes longer than that, at the end of our event. So feel free to send your questions in at any time. We cover different topics each month in the briefing room, and the reason we do that is largely because we're trying to empower you as an end user to get as many apples-to-apples comparisons of technology vendors in a short period of time. That way, if you are looking to pull the trigger on a deal, you have fresh information and fresh perspective on who does what and which technologies may fit or may not fit in what you're trying to do. So the topic this month is analytics, and we're doing this event on enabling analytics. So data virtualization is something that's been going on for quite a long time now. Composite is not a new company. They've been around at least 13 years. Bob can correct me on that if I'm off. But the point is they provide a virtual layer to data. So that involves a whole variety of technologies and techniques. But the point is that data virtualization is a method for delivering access to data that business analysts need. And as anyone in the data warehousing world knows, that has not always been the easiest thing to accomplish. So the bottom line is that there are multiple ways that you can deliver data, multiple ways that, of course, your analysts can consume that data. And the real trick, it seems to me, is to make sure you give those business analysts, those line of business managers, whoever it is in your organization who wants to do analysis, you want to make sure they have access to the information assets that they need. So data virtualization is one way to do that, and Composite has been doing it for about as long as anybody. And what they are doing these days, and I think Bob is going to talk a bit about this today in the show, they have a new set of offerings, I guess you could call it, that put more of a business face on the data. And I think that has been one of the missing links with data virtualization, is really not only giving access to the data to those business people, but also helping them understand what the data is, how that particular data set can be used, all the sorts of information around a data set that will help an analyst piece together in his or her mind what it is that they need to be able to do their jobs better. So the bottom line is you want frictionless analytics. You want the business analyst to have as little friction, as little pain as possible as he or she gets to the data they want in order to be able to slice and dice and get some information and get some insight. So, analyst Colin White, very happy to have Colin here in the briefing room. He's a veteran, both of our show and of the industry. He's been around for many years, was the founder, of course, of BI Research, and is very well known all over the speaking circuit, is very well known for doing webcasts. We're always happy to have him on here. He's got a new article on our website at insideanalysis.com right now that talks about data virtualization and data blending and data federation and these different terms. And, of course, it can be a bit tricky sometimes trying to distill which term means what in which context. So Colin does a pretty good job of ironing all that stuff out for you. So with that, actually I'll put one slide about Composite Software. As you can see, it's an enterprise-class data virtualization platform. Data virtualization can provide an agile, relatively low-cost solution with rapid deployment and quick iteration. So it's a good way also of helping to design more hardwired solutions like a data warehouse. And we'll hear from Bob Eve. He's been Composite Software's Executive Vice President of Marketing since 2006, and he also has a long history in the business, so he has a lot of experience to lean upon. And with that, I'm going to hand it over to Bob Eve of Composite Software, and I hand you the keys right now. And Bob, with that, the floor is yours.
Got it. Okay, great. Well, hello everyone. Colin, Eric, great to spend some time with you today. I'm going to talk about empowering the business with Agile analytics. I think it's kind of interesting, all the talk of big data and the volumes and the variety and the velocity, but we sometimes think about really the value of the big data and all data, and really the value of that is to the business, and analytics is often the path to that value. So I want to really bring together the thoughts of the business and analytics and providing a new way of, or some new approaches to be agile in that environment. So when talking about it, I'm going to talk a little bit about the analyst data problem, so what problem we're solving and for who. Talk a little bit about a couple of approaches to solving it, using a more agile approach, sandboxing and an analytic data hub, and then some of the benefits of that approach from a business value, cost agility point of view. Before I begin in the specifics of this topic, I want to go a little higher level with a couple of thoughts on I'm now the presenter. Okay, great. A couple of thoughts on data virtualization and how we can make that, and composite software in general. Okay, so let me get to this next slide. Perfect, okay. So, introduction to composite software. So composite actually has been around 10 years, and what we do is something called data virtualization. So let's just start with something simple. Why does data virtualization exist? If we think back, the purpose of data virtualization is a way to get information to the business. Traditionally, the data came from, almost all the data came from the data warehouse, and that was a good solution. But with the proliferation of all these other types of data, operational databases, enterprise apps, third-party data, the cloud, big data, etc., I think the business has been challenged to get access to all the information they really want in order to drive new decision-making, get value from that information, and take advantage of all of it. And IT has been challenged because, we have these different silos of technology and these different ways of providing information, and the traditional way to pipe everything over to the warehouse first doesn't really work for everything. If you've already got big data, why would you then move that into the warehouse? Some of the data in the cloud is not going to move into the warehouse, it's going to stay in the cloud, for example. So really, data virtualization exists to address this heterogeneity problem and provide a complement to the traditional data warehouse in bringing the business, surrounding the business with the data they require, getting that data to the business. It's a modern data integration technology that provides like instant access. You manage the data where it naturally lives, whether it's cloud, third-party, big data, etc. And composite software is 100% focused on helping our customers turn that data into business advantage. Now, who are some of the people that are using data virtualization? Let's take a quick look. This is a set of composites customers, and you'll notice data virtualization users from many industries, and of course there's a broad number of use cases far beyond just analytics. There's also a number of other customers that we're not allowed to use their logos, but let me assure you there's plenty more people using data virtualization today for very mission-critical information requirements. The way data virtualization works, a product like Composite, really, and a simple thing, if you really look at the top of this diagram, these are different use cases for information, business intelligence, analytics, governance, risk, and compliance. The data comes from the bottom of the diagram, all the different diverse sources, and what a data virtualization platform such as Composite provides is a development environment where you build the views or data services that will be consumed by the higher level information applications. You have a runtime server that performs the queries in a very highly performant fashion. And of course, you need a management environment in order to really manage and monitor the activity, ensure the high reliability, etc. So that's a quick introduction to composite and data virtualization. Let's dive into how we can use data virtualization to empower the business. it's funny. I talk to a lot of analysts about what they do. And when you talk to them, they get so excited about the models that they build, the statistical analysis they do to analyze the results and look for correlations and check how valid the model is. And then as they kind of work through that process to develop a business insight and then communicate that to the business and impact and improve the business. They are so animated when they discuss this process and the tools they use and et cetera. But if you ask them where they spend their time, it's amazing how much of the time they spend on the front end of the process just getting their arms around the data, finding it, accessing, getting access to it, get the data sets pulled together perhaps into a sandbox where they can then start to build the model. And interestingly, everyone I've spoken with says we spend more than half our time on this front end of the process. And it's so amazing, that they're such great modelers and analysts and thought and thinkers, technical thinkers, statistical skills, etc. But they spend a lot of their time just working the data, working the data, working the data. And they've gotten used to it. They'll laugh about the fact that they spend so much time doing the data. But, why is it that they spend so much time? Well, there is a lot of data to be found, and it's an iterative process. Each time you take a step forward, you oftentimes go back. Okay, well, that's not quite the same, all the data set I need. Well, once we've done the analysis, the correlations, I want to try one more factor, et cetera, et cetera. So they go round and round in an iterative, recursive process, and the time gets consumed. So what's needed to support a process like that are agile tools, automation, ease, self-service, things of those nature that kind of make that job easier. And in fact, wouldn't it be great if instead of spending more than half their time on the front end of this process with the data, they were spending more time on building the model, analyzing the results, and developing, communicating the business insight. So what would happen if we were able to take time out of this front end of the process? We'd get more insights sooner, and we'd get more business value sooner. And there's nothing wrong with that value proposition. So let's talk about how data virtualization can help. What I've done in these three columns is address the first three aspects of the first three chevrons. So let's start with the first one, find the data. Data virtualization is a very useful set of capabilities for identifying data, whether it's the local data on the analyst desktop or in the little departmental server, the enterprise data, for example, maybe your SAP or your data warehouse, and also external data sources. Perhaps it could be cloud data, for example, or something that comes in from an external service, for example, Bloomberg, stock feeds in the financial services industry. The other thing in terms of finding the data is once you kind of identify it and you can see the data sets that might be applicable, you still want to start to group them, search them a little bit, get a little better understanding of that metadata, of some of the characteristics of that data. At that point, you want to start actually touching the data. So we need to access it. So there's data virtualization is just loaded with capabilities for connecting to various data sources of all kinds of shapes, whether it's relational or hierarchical, and the access mechanisms vary from ODBC and JDBC to all kinds of fancy sourcing techniques. You can read a data sheet, and we described them all. But in that process, once you've connected to those sources, you can explore the live data to really get a sense of what's actually going on with the data. And that's oftentimes a very important aspect and something that takes a little longer if you're going to go all the way to a warehouse, because you have to build the schema, do the mappings, get the ETL working, and get it into and get everything transferred to the warehouse before you can really explore the live data. And in this recursive process, getting to that exploration of the live data as soon as possible is important. Finally, once you've kind of got your data sets together, one of the things that a product like Composite provides is an ability to generate an ER model. So we can actually kind of give you a sense of what the data model is across these data sets, even though these data sets might have come from different sources and don't really have primary key relationships. We can almost intuit certain ones and ask you if that's correct, and you could start to see the relationships between the data sets. Then you could start to use some of the tool to kind of start to filter and transform, aggregate, and provide whatever sort of work to kind of crunch that data a little bit more before you punch it into your before you leverage it in your model. And then finally, there's a real sense of, when I talk to analysts, they like to kind of get their arms around the data. And they like to maybe isolate it into a sandbox, which makes sense. So we'll definitely can provide ability to take that onto a desktop server or into their analytic appliance or over to a Hadoop, wherever the sandbox is, or selectively leave some of the data at the source. It really depends on what they're trying to do, but the flexibility at this point is to kind of get your arms around the data, create a sandbox, which from there you can start to build that model and develop and analyze the results, etc. So that's really kind of some of the capabilities that data virtualization provides to address the analyst data problem. If you look at it more from not so much the verbs or in the process, but think about maybe a conceptual analytic sandbox sitting between the different types of analytics or BI or visualization tools, whatever the case may be, and providing access to all the sources, connecting those sources, and really pulling those data sets together into some sort of physical, virtual, or hybrid sandbox. What you're really getting is the agility to connect those data sets, test that data, evaluate it, on kind of a self-service approach. These analysts oftentimes are doing this in a self-service way anyway, so providing the tooling to do that. The difference between the sandbox and the slide I'll have next is a data hub. I think the concept is similar. It's these data sets, but for a sandbox, it's I think more of the one-off type of analytics and a little bit more local control. And as we all know, the analytics, there's a lot of times you do an analysis and it's all throwaway. You just couldn't really get to a clear sense of insights, or maybe it's a one-off. So you're looking for, a one-time decision. So you're looking for techniques and approaches that are agile, can stand up quickly, get you the information, and then you don't have to maintain them. So I think a sandbox kind of works in that mode. If you want to persist the data sets, or you might want to do repeatable types of analyses, and share those data sets. For example, a marketing campaign analysis. You're going to do marketing campaigns on an ongoing basis, therefore you're going to do analysis on an ongoing basis, therefore you're going to use similar data sets on an ongoing basis. So rather than kind of have those in an isolated sandbox, maybe a more shared environment. We would call this an analytic data hub. There's perhaps other terms for that. But you still get the agility and the self-service, but more orientation towards sharing and reuse of the data sets, maybe enablement of a repetitive type analysis. For the example I just used being, of course, marketing campaign analysis. And you can kind of create a little bit more of a central control, or maybe maybe a little different balance between IT and which can bring some governance to the process and some greater capabilities in terms of surfacing the data sets on a repeated and regular fashion, as opposed to the kind of the one-offs or the approaches business likes to use. So as we pull those options together, we talked about a little bit about the process. We talked a little bit about a couple of deployment options in terms of a sandbox and a hub. What are the benefits? So I think the first and foremost, and goes back to this point about agility, the business needs the insight so they can create the impact. The faster they get the insight, the sooner they implement the impact. And so that time aspect, if we can help simplify the access to that data and accelerate that insight, that's going to flow right to the bottom line. So faster time to analysis is the critical benefit. I think it's an enablement of self-service data integration. And these users, these analysts, are typically doing a lot of self-service data integration already. And so we're empowering them, I think, with some better tools and techniques. But it's also a chance to rebalance the trade-off between a kind of a central IT and then the shadow IT that occurs whether or not IT likes it, in terms of supporting these data sets and that sort of thing. And I think what we've seen in some of the customers is finding IT becomes more of a service organization, surfacing these data sets, and then the analysts really take it from there. And so it's a different service level agreement between the organizations. And if you do this using some technology like data virtualization, you get benefits in terms of governance and security, etc. And then that allows for the reuse and consistency and quality. And one of the things that I think is really important is you can use these same data sets across multiple analytic tools depending on the type of analysis that you're doing. So you're not kind of locked into a stovepipe approach. Once you get a good data set, maybe in terms of a marketing campaign analysis, sometimes you'd want to use that, maybe with something with SAS or prediction or Alpine Data Labs. You just might be using the different things, or it may be something you want to use ClickTack or something else. So you don't always know how you want to use the data sets, but I think in advance, so as you create them, there might have reuse with other tools. So those are the benefits. Just kind of moving quickly here. Have people used this? Have they created, does it work? Well, I just want to go through a few quick cases that talk about this. We all know Comcast, and one of the things they were able to do was gain more insights by leveraging all their different data and doing analyses and figuring out ways to generate upsell revenue. I think more entertaining is, from a call to duty point of view, Sony Entertainment Network has also been able to drive up PlayStation revenue by accessing the data sets in terms of usage and changing how they deploy into new markets, etc. So definitely you can gain the insights you're looking for from an analytic point of view. You can pick up speed and agility and respond faster to these analytic needs. I love this quote from Pfizer where they're just that simple. They get information requests from the executives, and with data virtualization and Composite, they can respond to them 10 times faster than they could before. And I think that's a pretty, well, it's one way to become a hero in your organization, and that's definitely happened. But I think it's a pretty good testament to them. Actually, Qualcomm, I just got a note that there's an article in Search Data Management today about data virtualization and the value, and it talks about Qualcomm in that story. So if you're a subscriber to Search Data Management, you might want to check that out. Finally, you get the insight, you get the agility, and hey, save money too. What more could you want? Here's just a couple of cases from our larger customers. The Northern Trust was a outsourcing and use of data virtualization and outsourcing kind of mode. And of course, guys, everyone knows what NYSE Euronext does. So with their scope, they were able to save a significant amount of money. And both of these case studies are in our data virtualization book, so you can research those in a little bit more detail. With that, I'm done with my formal presentation, and I know it says Q&A here, but I know we're supposed to pop it over to Colin. So I look forward to hearing what Colin has to say, and then chiming in for the Q&A later.
There you go. And Colin, with that, I've handed you the keys to the WebEx. Go ahead. The floor is yours.
Okay. Hello, everybody. I'd like to thank the briefing room and Composite Software for inviting me to talk today about the whole subject of where we are with analytics and how we make them more agile. I always like to start really at this kind of discussion by looking at history a little bit. And if you've heard me present before, you may have seen this chart a number of times. But I think it tries to put things into perspective. So on the left-hand side, that little black and white diagram there is one of the first OLTP systems, which was Sabre back in 1960. And of course, we keep using the word big today. Well, big back in 1960 was a few thousand transactions a day, which was Sabre. If you look at Sabre today, in fact, they're processing thousands of transactions a second. So the concept of big is kind of changed over the last 50 years. And then, of course, if we look through the 60s and 70s, 80s, and 90s, we spent really 3 decades automating our business systems, point-of-sale terminals, ATMs, and of course now mobile phones, now using the internet and sensor networks. And then if we go to where we are today, this is sort of some big hot subject around big data and advanced analytics, and everybody has their own definition for it, a lot of hype around it. I think one way of looking at this is really that in order, in the web space, we came up with a whole bunch of new technologies to process large amounts of data and potentially do analytics on them. And those technologies have found their way into the mainstream sort of business intelligence and data warehousing. And I tend to think of big data and advanced analytics really as a set of disruptive technologies that enable us to really do things we couldn't do before from both sort of data integration and analytical viewpoint. And I think it's changed the way we do data warehousing. I think it's changed really the way we build analytics. And before I talk to Bob about where data virtualization fits into this, I just want to try and give a perspective of really the disruption this has caused. So if we look at our traditional data warehouse, really go back a few years and look at what people have done over the last, since data warehousing was invented back in the 90s. And what data warehousing did was effectively extract data from operational systems, integrate it and manage it in an enterprise data warehouse. In some cases, we spun out data marts and data cubes, which enabled people more to do interactive experimentation with the data in the warehouse. And then when we had a set of results, we would publish, we would analyze the data and then publish the results. So that's typically what we've done up until now. But of course, with the concept of big data, it enabled us to really to look at other data systems, both inside and outside the organization. And those data systems enable us to extend and improve what we want to do today, and in many cases enable us to build applications, business applications we couldn't build before. So if we look at our traditional workflow then, if we look at the access, integrate, and manage piece, we want to sort of blend in, bring in this new data. We want to discover this new data and figure out, what value it has to us from an analytical viewpoint. The issue that raises, of course, is the volumes are building both within traditional systems and these new data systems. And the question is, can we bring it all into, can we model it all and bring it into the enterprise data warehouse before we can actually analyze it? And that's becoming difficult to do. In many cases, a lot of that data we may not want to bring into the data warehouse initially. We may want to experiment with it to figure out what it can do, extract the business value from it, and then actually put it into the data warehouse. So we've got to improve the agility of building data warehouses. And then, of course, the other thing we want to do in the analyst and publish steps, we want to start investigating this new data. We want to try and extract business value. We want to discover new facts. So the question always comes up then is, can we do all this with our traditional data warehouse workflow? I believe that we can't. I believe we have to come up with a parallel workflow that works in conjunction with what we do today. And this is really this picture. And Bob alluded to this concept of sandboxes, and there are various terms for this, and we'll discuss some of those terms in a minute. So I think the concept of a sandbox, or an analytical sandbox, is a way of really finding out what data is out there, accessing it, and blending it together, and then investigating that information and trying to discover what business value is in this blended data. And then having really discovered how we can extract business value from that data, we could then actually use that subset of data and add it and model it into the data warehouse. So the idea here then is that we effectively sort of look at the data and analyze it and play with it until we can find the business value and then put it in the data warehouse. In other words, this is really a workflow that occurs before we even start thinking about modeling data for the data warehouse. And the advantage of that, it provides agility. We can quickly bring this data together, look at it, and make decisions of how we're going to use it and potentially bring it into the enterprise data warehouse. So these sandboxes have different names. We have BI tools today that do online analytical processing. In some cases, they extract data out of various data sources, either the enterprise data warehouse or other data warehouses, and they bring them into caches on OLAP servers or OLAP clients where people can interactively manipulate the data. And companies like ClickTech and Tableau do that. Then we have the data warehousing vendors, for example. Teradata enables you to carve off a bit of an enterprise data warehouse and use that for experimentation. We're seeing many analytical appliances from the mainstream vendors like IBM and Teradata and Microsoft and Oracle, plus new vendors like Parexel and EMC. Again, you can build these sandboxes. I often think of them as investigative computing platforms. And then data virtualization has a role to play here. Most probably, if I was redrawing this diagram, I'd put data virtualization under the Discover, Access, and Blend box, because what data virtualization enables you to do is blend this data together and actually create a virtual analytic sandbox. So in some cases, software like virtualization software like Composite enables you to persist that. So we can either have an analytic sandbox that simply is a virtual view of the source data, or we can actually persist it, and someone like Composite enables us to do that. And really that's what Bob described in terms of sandboxing from a data virtualization viewpoint. The question is, having really tuned this sandbox and got it really a view of the data we need to actually bring more into the production environment, we can take that sandbox, particularly if it's on something like an appliance, and put it into production, or we can blend the data or integrate the data back into the data warehouse. And then the role of virtualization then is not so much to produce virtual sandboxes, but more to act as a data hub. So I like Bob's approach of saying a data hub really is much more of a production environment for production BI, where we bring the data together and potentially bring it into the traditional data warehousing environment. But prior to that, we may use virtualization really to create virtual or even persistent analytic sandboxes. So that's the way I see the space then, is effectively we've got this new disruptive approach to try and actually experiment with data in a much more agile way, create sandboxes using various technologies that we can do investigation and discovery, and then based on those results, upgrade the production data warehousing environment. So I want to talk with Bob a little bit about this for about 15 minutes, and then we're opening up to the audience. And I really want to, the discussion with Bob, I want to address two areas really. One is the role of data virtualization in general in the BI and data warehousing space. And then secondly, look at how that fits into this new world of agility and sandboxing and data hubs. So let's start off by looking at virtualization. You know, Bob, you and I have known each other for a number of years, and I think you would agree with me that to begin with, virtualization concepts were a struggle to get adopted. But I sort of sense, although people may still be a little confused about its role, I think it's starting to get traction now. Is that a fair comment?
Absolutely, Colin. I think traction is a really good term. We certainly see it in both new customer adoption, you know, people who are buying in the last year, for example, but also in terms of, you know, some of the customers who did kind of go through that initial phase. We have very large adoption now, you know, we can get to enterprise scale. So definitely a higher level of interest what we see in our business. Gartner has some numbers on this, as does TDWI. In the summer of 2012, Gartner published in their hype cycle on data management that about 27% of the industries or any of the companies they had surveyed were either involved or planning to do data virtualization within the next year. TDWI's best practices report in Q1 2013 talked about 19% in use today, with another 31% planning to implement within 3 years. So I think, you know, we're really talking about you know, I agree with you. We've really reached a stage where the traction has picked up, and it is more of a question of not whether I'm going to use it, just how best to use it.
Yeah, so if we look at how best to use it, my sort of sense is that data virtualization got off to a bad start because people start talking about virtual data warehouse, in other words, the concept by which you didn't have to have a physical data warehouse anymore. You could create one dynamically on the fly using data virtualization, and we had the concept really of the virtual data warehouse. I sort of sense that term was discredited because effectively there are all sorts of issues about data quality, really performance and so on, and I sort of sense that data virtualization has really gained traction because we've moved away from this concept of the virtual data warehouse more to the concept of really saying, well, we have a number of different data sources when we want to make decisions, one of which may be the enterprise data warehouse, but there are other sources we want to blend into the decision-making processes. Would you agree with that? We've moved, virtual data warehousing has been discredited, and we're moving more towards the concept of creating a virtual semantic layer on a variety of different data sources so that the business user gets a common view of that data, and those data sources may in fact include an existing enterprise data warehouse.
Yeah, I think that's the model that people are deploying, and I think from a terminology point of view, let's decompose that virtual data warehouse. What do people like about a data warehouse, the traditional kind? What does business like? They like that schema. There's kind of a business view of the data, and you can get that, as you just mentioned, in data virtualization. So check, business schema. Perfect. They liked one place to go. Let's go to the warehouse, we can get the information. Well, today with data virtualization, it's kind of one virtual place to go, and then we'll route it to the data warehouse or the other source as appropriate. So check, that kind of works too. IT liked the data warehouse for, of course, because you mentioned it gives them a chance to do some governance and some management, as well as optimize the workload, and especially for these sort of time series analytic structures, they were able to structure the data. And today we know that there are many ways, different types of databases and different types of ways of doing the workload. So I think we've kind of decoupled some of those IT-ish issues of how you store the data from the business issues of schema and one, easy access and that sort of thing. So I think those are the elements of data virtualization that kind of match up with words like virtual data warehouse, but I definitely think that you're going down the wrong path if you start to think you're going to replace your big EDW with the multidimensional analysis for all of, a line of business or entire company with a virtual approach. It definitely complements.
Yeah, and one interesting term floating around, of course, is the one Gartner created, which was the concept of the logical data warehouse. I personally don't like that term because I feel really the data warehouse was an architecture. It was always a logical view, whereas people keep trying to tie warehousing to really physical data stores. But would you agree with Gartner's concept of the logical data warehouse? Virtualization fits into that very well, right?
It does fit very well, and again, it's a terminology challenge, as we all know. And we, in our industry, of course, we like to get the words just right. But I think the concepts are, if you really look at their research, they say, at the source, you manage the data with the best way to manage the data. It might be Hadoop, it might be a big EDW, it might be query on demand with something like data virtualization. Over those sources, you put a planning and control layer that kind of provides that governance and management ability, and then on top of that, you put, many terms, but a business semantic layer that translates all that IT taxonomy into something that's a business ontology that they can use. So I think those components are right. Again, we're challenged by the terms, but I think if people step back and look at what they're talking about, it's very similar to what you were talking about, Colin, on some of your extended data warehouse concepts.
So, we've got this concept then of this sort of semantic layer, business layer, view of various sources. And of course, one thing Composite's been working on is supporting an increasing number of sources. So as we blend this other data into this sort of virtual concept, do you think, are there any sort of sources, new sources of data you feel that dominate this discussion?
Yeah, I think it's kind of interestingly that the thing that's still dominating the discussion is the traditional enterprise sources, the transaction systems, the data warehouses, the analytic appliances. Those are the silos that we're typically integrating. What we've seen though over the trend over the last several years is more and more of the data is outside the firewall in the cloud. So, for example, maybe some Salesforce data, or it might be external feeds from something like Bloomberg financial information, and of course, big data. And right now, we've seen just very selective integrations of big data into, a data virtualization semantic layer. Like, for example, single view of customer. We might want the web logs that might be in big data, along with the information from the call center and maybe information from the transactions, the purchases in the past, etc. The email campaigns that might be managed elsewhere. But definitely, big data is probably the one with the highest acceleration as far as a new set of data.
Now, of course, the examples we always give are the customer-facing applications where we're trying to sell customers more stuff, right? But in addition to the front office, you're also seeing this in other areas like the middle and back office. Is that a fair comment?
Yeah. So, for example, one of our customers is financial in the financial industry, is subject to a lot of regulations. So the governance, risk, and compliance type of analytic loads are different than how the systems were originally designed, they tend to also have to go back into history and look for certain data. One of them is using a very interesting deployment of Hadoop for the archive data, and then they can use Composite across the Hadoop archive data and then the live transactional data and some of the warehouse shorter-term historical data, and they can then do compliance and risk analyses across those warm, medium, and cold data.
Okay, let's move on now and drill down a bit into this whole concept of agile analytics and sandboxes. I've sort of presented this as a parallel workflow. In other words, we have a traditional workflow where we integrate the data first into a warehouse and then analyze it. And the comment I made was that it's increasingly difficult to take all these new data sources and integrate them into a warehouse first. So we have this parallel workflow by which we want to blend the data together into a sandbox, possibly using virtualization to create virtual sandboxes or persistent sandboxes, and then decide, well, we may put that sandbox into production as a separate line of business application, or we may use it as a way of sort of prototyping the data and modeling it before extending the data warehouse. I mean, do you agree with that view?
I do. I think, we've sort of historically had this traditional BI that was a very deterministic process. I need a report that looks like this. And, we had a nice SDLC that included data integration and reporting and drive it through the warehouse and the marts, et cetera. And that wasn't the most agile thing in the world, but it definitely worked. And because it was very deterministic. I think with an analytics, it's much more the scientific method. It's observation, hypothesis, experiment, evaluation of results, iterate. You just keep doing that, and some of the times there's no answer. It's all throwaway. We couldn't figure out what the best next offer was supposed to be. Or it might be something that's a one-time use, or it only gets beyond the personal environment, that only stays in a personal environment for a small group setting. You don't necessarily productionize something like that. But then in other cases, let's say we have figured out a nice algorithm for next best offer, that needs to be productionalized probably out at the call center, at the call center agents. So, or maybe it's a certain data set, a couple of data sets that should be loaded to the warehouse in order to support that ongoing analysis, because we might already have lifetime value in the warehouse, for example, lifetime customer value. So I think the idea of these parallels is part of it, and also just the idea of the processes used for analytics just have to be more dynamic than the traditional BI processes.
Mm-hmm. Now, you know, I use the word data exploration and discovery, and I think a number of vendors are using that term now. We tend to associate often those terms with search. In other words, using search to discover information. Where do you see search fitting into this?
Well, you know, if you go think back to that diagram of chevrons, find the data was the first step. And so to the extent you can use search techniques along with, you know, traditional review of data introspection, you know, introspection techniques and ER diagram evaluation techniques, I think go after it any way you possibly can, see what data's there, and then you could get to the next step of, you know, accessing it and then starting to pull it together for use in the analysis. So definitely a valuable value add.
So if we look at your customer base, I suppose I have two questions. One is, how many of them are you know, rather than just using, say, virtualization as a front end to the traditional workflow, you know, how many of them are really using virtualization in this sort of more agile mode? That's the first question. And then the second question is, you know, when it comes to sort of productionalizing that, are they just taking the sandboxes and putting them into production, or are they simply using it to design and extend the data warehouse?
Great question. So I think any customer who uses data virtualization is by default using a more agile approach. You know, I think I mentioned in my presentation Pfizer's 10 times faster. Sometimes those 10 times faster to fulfill enterprise or executive information requests. Now, sometimes those might be considered analysis. Sometimes that might be considered just, you know, kind of lighter BI, self-service BI. But I think that's pretty much a common denominator, just because there's fewer moving parts when you're building a view and surfacing it to the tool or to the analyst than when you're trying to, you know, map to the warehouse, etc. Now, how often do those data sets then get moved to the warehouse? I think a lot of that depends on the nature of the the queries in general, what kind of problem they're solving, etc. We actually, you know, I worked with your colleague Claudia Imhoff and then Ted Friedman over at Gartner to develop a physical consolidation versus a virtual data virtualization approach decision tool that kind of based on different characteristics of the source data, characteristics of the consuming app, characteristics of the business, etc. You might want to ultimately end up with a consolidated data set or a virtual data set. So we have that tool. It's available on our website. It's also now integrated in the TDWI's data virtualization class. So it's kind of public domain information, kind of helpful. But I think a lot of times people will prototype with data virtualization just to quickly get their arms around the data sets and kind of almost, you know, if they want, then they've got the schema that they need.
Okay. Now, you know, virtualization again can be an abused term. I mentioned in my presentation, you know, BI vendors often use the word data virtualization. So vendors like Tableau allow you to sort of analyze data from multiple sources, and ClickView and companies like that. And even sort of SAP with HANA are saying, well, we don't need virtual warehouse, we don't need physical warehouses anymore, we can use virtual ones. So let's look at the BI piece mainly. What is the difference between what Composite provides and, say, what a BI vendor like Tableau or ClickView provides?
Sure. I think the nice thing about what Tableau and ClickView do is they're kind of an excellent data exploration all the way through visualization. So it's kind of a one-stop shop end-to-end. And they have some reasonably good data integration techniques. With Composite, it's definitely broader and deeper on the data integration half, and we don't have the visualization half and the analysis half. So we're much more broader, deeper in terms of the sources we can access, the performance of our queries, the domain knowledge and expertise on that sourcing of the data side. And then once you've used something like Composite, you're flexible to use whatever reporting or an analysis tool you want on those data sets. So if you're an Excel user or a ClickView user or a Cognos user, it's still the same. You can use whatever you want depending on the problem. So it's a little different approach. We've taken to being the best of breed at kind of the bottom half of the data half, and there I think have a pretty good data solution with a really high-end, nice visualization analysis solution.
You're almost like a virtual database engine. I want to leave some time for the audience to ask. Let me just finish off then. What do you think are the limitations of virtualization, and where do you see it going next?
Well, I think it's interesting to parallel data management is very complex, and sometimes you use a relational database, sometimes you use columnar, sometimes you use a key value store, graph, Hadoop. I mean, that's become kind of accepted that we're going to use different data storage and management techniques based on the characteristics of the problem we're solving. I think data virtualization is similar. There's certain cases where you definitely make sense to pre-consolidate the data. Other times, just replicate the data, and then in other cases, you want to virtualize it. So I think it's a big it depends. As I mentioned, that tool a moment ago, I think helps with some of the decisions in terms of the nature of the queries. Are they broad, shallow queries, or are they deep analytical? Time series type analyses. So I think those are the questions. Interestingly, Wayne Eckerson, BI Network, said at our conference last fall that he said, I don't know why you wouldn't at least try data virtualization first. And if that worked, just stick with it. So I think that's an interesting take on it too. So in trying it, you'll expose whether or not you hit the limitations. I mean, it's kind of a fail-forward approach, but certainly it'll be much more agile and could make your business a lot happier.
Okay. So Eric, we've got I think 10 minutes left. Why don't I hand it back to you and open it up to the audience?
Okay, good job. And yes, Bob, we have quite a few very pointed, very, very excellent questions. Thank you again to the audience for helping me deliver good content, because you guys are out there in the real world trying to get this stuff done. So let me just dive right in, Bob. We have probably 6 or 7 great questions. So let's see. The first one, what is a typical support organization makeup in terms of skills and numbers of people required to support a composite implementation, especially for a large global multinational?
Wow. Do that one again, because that's a big question.
So basically he wants to know, this guy works for a very large multinational organization. If they bring you in, what kind of support team are they going to need? How many people? What do those different people do? How much consultation to get it up and running and then ongoing?
Sure. If you remember a diagram a little earlier where I talked about kind of there's a development environment, a runtime environment, and a management environment. How many people to develop really depends on how many views and services you want to create, how quickly. And in terms of the administration and management, most of our users have customers have a very small administrative support function. It's a standard Java-based server. It fits in a rack. It has management tools that can run independently, etc. So in a sense, it kind of depends on how big you want to deploy. You can certainly use the same from a skill point of view, the same people you already have in your integration competency center. Probably have some good SQL knowledge, have a good sense of the data that they're typically pulling together, some of the different techniques and approaches, some familiarity with the data sets. So I think the skill levels there's not any additional high-end skills that are required. Our optimizer kind of pretty smart itself, so it does a lot of the optimizations. There's some fine-tuning where you might want to get some people who are a little higher skilled in terms of query optimization and how to use our caching techniques and understanding the various capabilities of databases. So Netezza versus ParAccel, for example. But I think the skills are pretty much every IT shop has those skills.
Yeah, right. And I'm quite sure at least that you guys have integrated fairly well with SAP Business Warehouse. What about HANA? How do you guys integrate with HANA?
That's a great question. We can certainly access HANA as a source. but I've got actually a white paper on the site that's data virtualization and HANA, written by Rick Vanderlands, and he kind of talks about what's HANA, what's data virtualization, and how they compare and contrast. And his recommendation is use both. I kind of like the recommendation, to tell you the truth. But that paper is available free on our website. So just anyone who's interested in that, take a look.
Sure. And here's another great question. A lot of good ones today. You and I, Bob, have talked about this before, about integration with the cloud, because the cloud is getting bigger. Let's face it, there are more and more providers out there. Obviously, that's all API-driven, or at least largely API-driven. One of the attendees is asking, how do you see orchestration of cloud data services in today's multi-cloud provider environment? Have you done anything in particular, or is there a particular part of the tool that focuses on that?
Well, I think, let me decompose it a little bit. So, for example, we have a customer, Putnam. It's a mutual fund company I think probably everybody's heard of. They use Composite to kind of integrate the data for their marketing campaign analysis. Some of that data is from a cloud provider that does the actual back-end mutual fund management of the trades and the balances. Some of it's Salesforce.com, where the investment advisors are using Salesforce.com to coordinate their interaction. Some of it's internal data. Some of it's big data from traction on the website. So I think we just look at the cloud as just another source. There might be some we definitely need to deal with the security of that source, but we always need to deal with the security of the source. There may be some latency issues, a little different for cloud data. Depends on the nature and scope of the query, so we'd want to definitely look at that. And you might end up having to do some caching, local caching, in order to get the query performance you want if you're going to pull big data sets from across the cloud. But I think that's true of any kind of data sets.
Right.
Yeah, and we say that network latency applies to any data integration tool. Really, if you're bringing data out of the cloud into the enterprise, either dynamically or even via ETL engines, the latency of that and network bandwidth is a key consideration, isn't it?
Yeah, absolutely.
Yeah, it's interesting that I've heard more and more lately about network bandwidth than I've heard it in quite a long time. So it's just kind of funny how the pain point just seems to move around the cycle a little bit. You'd have to kind of follow the rabbit and improve it where you can. So let's see. Here's another really good question. Can you talk about, and Colin mentioned this, but can you speak to this concept of logical data warehouse? And I mean, do you think it's a term that really makes sense? Does it add something to enterprise data warehouse, or what's the big difference, I suppose?
Well, I think if going back, remember a few minutes ago, I talked about if you decompose what the word data warehouse means. It means to the business it's a semantic view of the data, a nice business view of the data, and kind of one virtual or one place to go. I think logical data warehouse does a reasonably job connoting that. But what it also, I think, does is recognize that we are going to be in a heterogeneous, siloed data management world. All the data, even the majority of the data is no longer going to come from the warehouse. There's just too many other reasons to have optimized data storage and management techniques. And there's too many of them. And you mentioned a minute ago as the opportunity, as something moves around, the bottleneck goes to a different place. But also as it's moving around, it's created new opportunities and new successes and new capabilities. So I think the logical data warehouse tries to reconcile the fact that we've got all these new opportunities in terms of data management, data storage, but we still want to provide the business one place to go. Nice, simple business semantics that hide all that complexity, and it's getting even more complex by the day.
Can I have my 2 cents with that?
Yeah, please.
I mean, the good thing about the term is it gets us back to it thinking in terms of business views. In other words, I think there's a great tendency recently for people to think of enterprise data warehouse in physical terms, physical data stores. I was talking to Wayne Eckerson recently, and he was telling me that he got into a fairly detailed discussion with one company where they were dumping all their data into Hadoop and then spinning the data out to various targets, one being Teradata, and they said, well, in that case, Teradata is a data mart. And I think what got lost in that discussion was just dumping data into a data store doesn't make it a data warehouse. It's a semantic view. It's the business putting the data in a form the business user can use. We shouldn't think of a data warehouse in physical terms and data store terms. We should think of it in terms of business views, and those business views may be of integrated physical one data store, or it may be virtual data stores.
Yeah, and I just think in general, if people just kind of step back a little bit from the terminology, I understand, the terminology is very helpful, but just kind of step back and go, well, what problem am I solving, and what capabilities, do these different great technologies bring to bear on the problem, and how do I want to solve my problem? And if it has a label, that's great, but if it doesn't have a label, how about the label solve my business problem? So focus there.
No question. We actually have several questions around the same topic of performance and of impacting the systems from which you're grabbing data or even to which you're delivering data, but usually I think they're talking about where you get the data from.
Sure.
Can you talk about what has changed in that space? Why is that less of a problem now than it was 5 years ago?
Well, everything's changed in that space, frankly. First of all, the sources themselves cut so much faster. And we use push-down optimization techniques, and they can surface data sets so much more quickly. Our optimization algorithms, in terms of their performance and the compute power and the network latencies, et cetera, all that calculus has changed for the better. We have very advanced caching techniques, so should there be a data set that we want to persist and hit a number of times, and when we do caching, it isn't just a SQL insert into the database nearby. We used all the bulk loading and parallel loading techniques that come with advanced appliances and the data warehouses, et cetera. So it's really we turn the dial on every opportunity in terms of sources, the whole flow, and options like caching. So I think we bring a lot of stuff to bear. And remember, the optimizers work automatically. And if you to try to figure out the best possible query path for that specific query.
Yeah, and so that's actually a good point that you bring up the optimizer, because that is a big part of the equation here. I'm wondering, can a user get any visibility into how the optimizer is working? In other words, when a change is made to optimize a particular access path, essentially, is there some kind of report that comes out which can explain to the team at the company what happened and why that happened?
Oh, yeah, absolutely. So we keep here's the query plan that the optimizer used to execute that query. And it's kind of interesting because you can see, just based on different conditions and cardinality and stuff, how some queries that are seem very similar could end up with completely different optimization plans. And then you can use that, and as I said, the optimizer tends to do most of the work itself. You can override it. You can give it the equivalent of hints. We don't call them hints, but the equivalent of hints for those Oracle folks. And we can do, as I said, caching is a manual design intervention. You'd have to design that into the process, but once you've built the cache and the cache is automatically getting updated as it goes in the process, the optimizer knows to go to the cache if the cache is there. It doesn't necessarily, again, have to go to the original source data. It'll figure that out on its own. So.
And that's the big difference, isn't it? I mean, we'll go back to the discussion about client-based virtualization that I tend to call blending, and I covered it in the paper Eric mentioned, that really if you move towards more server-based virtualization like Composite provides, you've almost got a database engine in there, haven't you?
Yeah, it's like, sometimes I talk to people who say, well, you know how a database has a schema and a query engine and an optimizer. We just have done that across multiple databases, those same components. So that engine, our engine runs across multiple databases and does that work. And I mean, the company's been, it's 10 years, 300 plus man years of development. A lot of that's been spent on the optimizers, and it's kind of what we get excited about in the engineering group. They just love doing that stuff. And I think that's where the real intellectual property of Composite is.
Yeah, and here's a really, really good question, and one that I think kind of speaks to the new way in which people are thinking about data, and it really does articulate what I consider to be sort of a hallmark of the way to deal with these kinds of things. The question is, does Composite offer a way to crawl or index data sources? And I'm thinking the crawl side, first of all, like the search engine Bing or Google will index web pages.
Yeah, so the way we do that is, first thing we can do is you point us at a system and we can introspect it. So we see all the structures of the data, the schema, etc., the tables, the column names, etc. So first thing we do is we get a sense of what the data is, how the data is set up. Then we have a discovery tool that allows you to then go do a couple of things. We can point it at the data itself and then start looking for specific attributes in the data and start to try to make inferences in terms of relationships, or we can just point it at those introspected structures and then try to make inferences about the data itself. So that kind of helps in the rapid creation of a ER diagram and a good understanding of the source data. It's more designed as a design tool in the front end of the development of a data integration of a project. It's not really designed to be end user search. It's more the developer agile rapid time to development SDLC tool.
Gotcha. And that actually is a great segue to another question. We'll take just a couple more. Is how do you deal with data governance for Agile analytics compared to the traditional approach, which typically is not tremendously agile? So how do you handle the whole governance side of the equation?
Well, I posit there's a third traditional approach, which is avoid all of IT and do it ourselves, right? So the other traditional approach, the cowboy approach, right? So I think we sit somewhere in the middle of an extreme, centralized governance schema model, and then a more flexible agile schema with, we can provide all the security tools that we apply all the security that go with the source and the consumer automatically. We can provide full lineage and where used, so if you want to really track where the data came from, etc., or where it's going, you can see all of that. So there are some definite capabilities that in the technology that enable a degree of governance. As I said, probably not as tight as what you'd get in a traditional EDW environment with a lot of governance built into those processes over time, but certainly maybe a better place than these analysts have been in the past, and maybe a little different service level agreement between IT and those analysts, whereas before I think there wasn't any agreement at all, or governance.
Okay, good. Good point. Let's take two more. One of the attendees wants to know, what are the enhancements we can expect in the upcoming releases of Composite?
Sure. We talked about performance before. You'll always see performance enhancements. We're also working a lot more on the ease of use for our business analyst type user as opposed to the developer. And I think the big data appliance and the analytic appliances continue to proliferate, so we're adding those sources. And remember, when we add a source, it's not just a dumb ODBC connection or JDBC connection. We really have to understand the optimizer. We really have that source system. We really need to understand how you do a bulk load or a bulk extract from that database so that we can use those techniques in our optimizations. So we've got a few more of those coming down the pike. And it's fun, if you look at our data sheet for the companies we already have supported in that front, and then you can say, well, who are the other 2 or 3 analytic appliance vendors who aren't on that list, then you can pretty much guess who we're going to build next.
There you go. And I'll throw one last question over at you. One of the things I keep thinking about is the power of these new, many of them open source database engines, the NoSQL, so to speak, engines, and the speed of writes that you can get on some of these things. And granted, they will write in a very particular fashion, which needs to be catered to in order to really leverage that power. but are you guys looking to incorporate that kind of high-speed write capability into your tools? Because after all, a lot of the stuff, at least the garden variety, is open source, and it seems to me that the speed of these database engines really does change the game in terms of your information architecture and your data flows throughout your information architecture. What do you think about all that?
Well, I think we focus so much on data set reads. I mean, that's the, where all our IP is, and then the solutions we're typically deployed in. When we get involved in writes, they are very selective, and they're not often, they're just kind of maybe final write-backs or small changes to data sets, etc. So it's not really the domain where our users have really deployed us, and the necessarily highest on our list of focus areas.
Cool. Okay, great answer. Well, folks, we do archive all these webcasts at InsideAnalysis.com. Look under the Webcasts tab, and you'll find recent episodes. Check that out right there. And let's see. Well, let me throw one more question because we just got a last-minute one here. Is it one of the key capabilities of an analytics sandbox to write custom user data sets? Good question.
Yes. As Colin mentioned, there's different ways you can actually physically or virtually deploy a sandbox in your environment. It could be an analytic engine, it could be an analytic appliance, it could be a partition of your EDW, it could be virtually, it could be your desktop, etc. So the physical side is definitely there, and then those data sets. Really, I think the whole concept is what's the data sets I need as an analyst in order to do the specific analytic that I'm doing. So I think that's the way to think about it.
Okay, good. And folks, you can see this month is analytics. Operational intelligence is next month. Business intelligence is April. Integration is May. I think you'll be hearing from Composite again come May. And with that, we are going to bid you farewell. Excellent event today. Very big thank you to Composite. Very big thank you to our friend Colin White from BI Research for giving us his time today. With that, we will bid you farewell. And once again, you can check out the archive at InsideAnalysis.com. Thanks again, folks. Take care. Bye-bye.